Yes, welcome everyone to GeoHug. So before we kick off today's session, I'd just like to take this time to acknowledge the traditional lands which we're all coming from today. I'm here on the beautiful lands of the Gadigal, of the people of the Aurora Nation, and I'd like to pay my respects to the elders past, present and future. So I'm so happy to have Mark Arundell joining us today. So Mark consults as a geologist and geochemist, and currently most of his work involves integrating geology and geochemistry in the search for copper and gold mineralization. He spends quite a bit of time looking at other people's geochemical data and is therefore passionate about collecting quality samples in the field. So he'll be talking to us today to stop sampling rubbish. So it is going to be a great session. I hope you all enjoy it. Please keep using the chat. We'll be opening up the floor and having some discussions at the end. And yes, thank you so much, Mark, for joining. It's awesome having you.
So look, first of all, thanks to Jess for actually having us on board. It's taken a while, but eventually it was going to happen. And look, I'd like to start by saying congrats to Jess for putting GeoHug together. I'm just trying to minimise something. GeoHug was a great big part of the COVID lockdown, and it's great to see it's thriving in a post-COVID world. The talks that Jess has put together, I'm finding a great resource, and I'm finding I'm able to refer clients to the talks on the website. So I think we should be really grateful to Jess. She's done a great job, and she should be really proud of what she's actually done. Oh, I can see a thumb already. Thank you, Graham. I gave a talk similar to this in Adelaide 4 or 5 weeks ago, and someone came up to me after the talk and told me it made a lot of sense. Those sort of things get me a little bit worried. I'm a big, passionate talking heads fan, and one of my favourite albums and movies of all time is Stop Making Sense. So hopefully we can make sense today rather than following on from David Byrne in some ways. If you're interested in some of the background to this presentation, IMEX Consulting has a presence on LinkedIn. A lot of the stuff that's background here is on the LinkedIn site. And yeah, that's probably a good way. I'm not going to be able to cover everything in this short amount of time. The other thing I'd like to do is say thanks to Peter Walker and Ahmad Salim, who have provided some input into this talk and got to see an earlier draft of it and gave me a few things to think about. So where do we begin? The story begins in South Australia about 10 years ago. I was working for a junior South Australian explorer, and they had a JV with a major North American company. One of the prospects, it wasn't called Donkey Bore, but it's best that we refer to it as Donkey Bore, was located maybe about 100 kilometres away from Olympic Dam, and there was a series of other prospects in the area. The really interesting thing about the joint venture agreement was that it had a clause where the work needed to produce a drill target or the junior explorer didn't have to pay for the work. So the North American company conducted soils over the area. Now, that might seem a reasonable thing to do, but basement was probably in the order of 800 to 1,000 metres below the surface. So at a joint venture meeting, I asked, I thought, a fairly obvious question: if you actually discover an anomaly here, are you going to drill it? And they said no. So consequently, the $30,000 to $50,000 that it cost them to fly a crew over there to actually do the soil sampling was not permitted as part of the joint venture expenditure. And that really got me thinking about our approach to cover and what we think is actually a reasonable thing to do. So if you want to take a golf analogy to it, which I will do, they probably were in the right fairway. The Olympic domain is a great place to go looking for a new Olympic dam, but soils potentially was the wrong club selection. So the idea of using golf as an analogy for exploration is not mine. And I'd like to thank Dave Giles, who gave a talk at Mines and Wines a couple of months ago, who actually introduced this to me as a concept. And I didn't actually realise how much exploration is like golf. what I didn't realise until I caught up with Dave recently is how much I've expanded on it, and hopefully it'll make some sense to you people as well. So I firmly believe you should start at the end. So here I am, standing on the green, next to the hole, looking back down the fairway. The hole is the ore body. The green is a near miss, and hopefully you're on the tee. And even better if you're asking the question, what do I need to do to get to the green or into the hole? So the question I like to ask clients is, well, what are you trying to achieve? So you may not actually realise it from the image on the screen, but the tee is off to the right. The hole does a bit of a dog leg, so you can't actually see the green, let alone the hole from where you're about to tee off from. So it comes down to a question of club selection. What techniques do you intend to use? Are you going to use a putter on the tee? Are you going to use a wood? You know, that might get you some great distance, but it might splay off. It's like taking a big stick to it. Or you might decide to go for the safety of a 3-iron. But what you want to do is to avoid the water and the bunkers. Now, I quite like this lady here. She's taken a wood. To me, that's like taking airborne EM in the search for massive sulfide copper. The target in this case actually looks a lot closer than it actually is. It's actually about a 450 metre shot to actually get it onto the green here. So taking a wood to it is not a bad idea. I like the fact she's not distracted, she's facing in the right direction, and she's focused on the target. So how do we avoid sampling rubbish, or as a friend of mine likes to refer to it, avoiding suboptimal? Well, first of all, you need to be on the right fairway. You need to be in the right area. And before you start, you need to know what that fairway is. You do your lit search, your homework. You might actually have a few swings in the background to practice a few things, and you might call in a consultant like your caddy who's actually walked the ground before you. The best thing you can do is stay on the fairway. Don't shoot sideways, don't shoot backwards. And as far as I'm concerned, the best thing to do to make it as cheap as possible to get to discovery is to take as few shots as possible. Look, at the end of the day, maybe it doesn't matter how many strokes you take, as long as they're focused on them and achieve the target. And then it comes down to selecting the right club for the area. The other thing to remember is that the hole can move on the green. And by that, I mean that the first ore body that was found may not be identical to the second ore body that was found. The green in that sense is near miss, or a close approximation to where the mineralisation is. But the new ore body, and I'm thinking of something like Ernest Henry relative to Olympic Dam, could actually be in a different position sitting on the green. And that brings me, I suppose, to the main thing I'm going to talk about today, the regolith. What is the regolith? Well, simply, it's been stated that the regolith is the distance or the material between fresh rock and fresh air. So that could include saprolite, it could include soil, it could include rock, it could include lag, it could include till, if we're talking about a European or a North American context, actually in the Arctic. So what the regolith does is make the hole or the green a bit of a bigger target, and that's why the regolith is quite a good place to explore in. So to expand on that a bit further, I've got this nice little diagram from Ryan Noble on the De Crusser deposit. If we're looking for primary mineralisation, we may find that the primary dispersion extends just a short distance away from the mineralisation. When we're in the secondary environment, it can actually be 10 times larger. And then the interesting thing about this particular scenario is that the dispersion occurs into the saprolite, also into what's logged as transported cover. And I want to talk about transported cover later. But the really interesting thing for me here is that if you did some surface sampling of that sandy soil, the yellow layer, we'll just ignore the trees for the moment, that's basically useless. In fact, sampling that would provide probably a non-optimal medium to sample and give you some very ambiguous results. In fact, probably rubbish. So where do we start? Where is the first, or what is the first club that we select? And to me, the first thing you select is a map. And one of the things I like to use to actually start putting my map together is satellite data. I'm finding Sentinel-2, which is like a modern day Landsat, fantastic data to start with. Comes from the European Space Agency. It's free. The natural colour image on the left-hand side there has a 10-metre resolution, and it's flown, I think, in the range of every 7 to 14 days. If you're not using it and would like to know something about it, I'll put a couple of videos on the IMX's LinkedIn site on how to actually access the data and how to process it and map info to get an image. Really, really simple stuff. You can also do it within QGIS, and I'll mention Grant Boxer here, and hopefully he won't throw any rocks at me. But yeah, Grant's actually done something with Sentinel as well. You can enhance the images. This is one from WA, Western Australia, I did recently, to tease out stratigraphy, the type of regolith, and also structure. And one thing that I'll point out from this is that I'm not interested in actually producing a pretty map out of it with pretty colours. All I'm interested in the end is one boundary, and to steal something else from Lord of the Rings, one boundary to rule them all. I'm only interested in the boundary between where I'm going to surface sample and where I'm not going to surface sample. So the regolith map, when I'm producing that, the first thing to do is to overlay a geology map to identify where the rocks are sticking out of the ground, the basement, and then identify areas of quaternary or Cainozoic, alluvium and drainages to identify a depositional regime. And then in between the two is the difficult work. One is the pediment, which you may see different tonal variations, and pediment is where the subcrop or the soil or the lag occurs. And then I also use another term called intermediate, which I generally classify the colluvium into that. That actually might be pediment, or it might actually be depositional, but it's an area where potentially you can still sample. So that BPID classification, I'll thank Brian Senior for that, who actually did work for Renison Goldfields in the 1990s. He basically came up with that classification, which I still use today. I drape an interpretation of that onto 3D topo, if I can get that, and review it. And that's what I call a draft regolith map. And the reason why I call it a draft is it needs field inspection. I identify areas of uncertainty and prioritize those for the field work. I take real high-tech equipment out. I take some sieves, I'll take a hand auger and a spade into the field, and I'll dig some holes and I'll walk the area. And when I've actually tightened up my boundary, and the other thing is the boundary only needs to be as accurate as the surface sampling spacing, then I'm actually ready to sample. Basically, I'll try and just have the basement pediment in intermediate regimes for sampling, and the depositional areas, the covered areas, if it's considered high priority, I might actually look at doing something what I call calibration drilling, which basically means trying to work out how deep the cover is. The photo on the right, you may actually notice that the only thing that's being collected is actually the plus fraction. This is called a lag sample for some people who may not have been exposed to it. I've often referred to lag sampling as a lost Jedi art, and you can see down the bottom is the fine grain material, which is not actually soil, which is actually not being collected. If you're really interested in this and you don't have a copy of the latest edition, the 5th edition of the Field Geologist Manual, there's some excellent work by Richard Mazzucchelli in there. And I like this one. It's a great illustration of how a technique should match the stage of exploration. For example, in an area of moderate to high relief, drainage sampling is an excellent reconnaissance sampling technique. However, where you have less relief, you may actually need to go for lag or soils. A follow-up to both of them could be more detailed lag of soils, and then we can talk about some sort of weathered bedrock or delineation drilling as we move through the exploration process. Sample spacing, I equate to bulk density recording in drilling. It's something that people underrate quite significantly. One thing I like to do is think about how big an ore body do you want to find, or how small a target do you actually want to get. And that comes down to, because I like to do exploration as cheaply as possible, I want to take as fewer samples as I need to take to actually find what I'm looking for. So maybe you're happy with a point anomaly for follow-up, or maybe you want a cluster of anomalies to follow up. That basically then will help you determine what your sample spacing will be. Reconnaissance sampling should not be detailed. It should not be in the order of 50 by 25 when you're doing the first pass regional reconnaissance sampling. So here's a question to put into the chat box. How large a sand particle can be moved by wind on Earth? So it's either 0.5, 1, 1.5 or 2. So we're all geologists. There should be no reason why you're not prepared to be wrong. So I would love to see someone, oh, we've already got one vote there in already. Now, there's a few there.
I got a couple direct ones, a 2 and a 1.
So far, no one's got it right. So if you ever get a chance to have a listen to the podcasts called, I think it's Geology Bites. I forgot, I'll see if I can send it through to Jess later. But Mackenzie Day and her team from UCLA have done work in a wind tunnel with sand. Mackenzie is actually a specialist in aeolian deposits. And the answer is B, 1 millimetre. You might think, why does that matter? Well, if you're taking a minus 1 millimetre soil sample, what could you be collecting in that sample? If you're working in WA and there's sand plains, you're likely to actually have quite a lot of aeolian, potentially have a lot of aeolian material in that. Even if you're collecting a minus 2 mil in a potential aeolian regime, you could still be diluting the sample quite significantly by the sand factor there. So all I'm suggesting by this one is that maybe you should actually think about where you can is collecting a plus 1 millimetre sample. Thanks for that, Jess. Yeah, those geology bites are really, really good, particularly if you're doing long trips out to Ninken. So I could read this out, but I'm just putting it basically up there. Collection is actually really, really critical. You want something that's consistent, uncontaminated, and something that it makes it easy to get it right. And this guy on the right is doing a great job of sampling exotic sand going into the craft bag there while he's discarding the in situ lag, which is in the pan between his legs. And you can also see the amount of rock that's actually occurring in that area. So look, you can minimize cost and time, but you actually really need to actually identify, are you taking a decent sample to start with? And that's from an ASX release from 2022, like in the last couple of months. So what about the depth? How deep do you need to go? Can you actually take something on the surface? Well, you can see in the little photo on the bottom right-hand corner, there is actually a little bit of what looks like soil in this area. I can tell you that's exotic material in this particular place. It's about 10 centimetres thick and it's geochemically inert. Once you get underneath that layer, you drill straight into weathered bedrock with the auger. So you need to actually understand it. So, and that's part of the reason why when I'm doing the regolith mapping, I actually use tools like a spade and an auger to dig holes. One of the things I think people underrate is how simple you actually need to make your sampling. Who's going to do the sampling? I spent a lovely day with these two guys out in the field and we drilled probably about 30 to 40 holes. Every single one of them I logged and I showed them what I was logging as we were actually doing it. And these guys became very keen, shall we say, backyard auger geologists. But more to the point, if something went wrong or they saw something different, they took a photograph of it and sent it to me straight away. The other thing is that I gave them a map of where the points were and we downloaded all the sample points onto the GPS. So all they had to do was actually go out and take the samples. They put a few chips in the chip tray for me from time to time, and I would actually log that material. So keeping it as simple for them out in the field made it really, really easy for them to get it right. Their job was to sample, not to do the geology for them. So coming back into the Field Geos manual again, and I've just basically taken this from another section that Richard Mazzucchelli's written on soil sampling. Just basically put this one up here. I suspect that where this sampling is occurring is on a candesol, or basically on a sandy soil, a sand area where a soil is developed on the top of it. He's got a normal kitchen sieve there, which is around about that area of 1 mil. So I can tell you that I'm highly likely that what's going to go to the lab there is a sample of aeolian material rather than a representative of the material that's actually underneath what the guy thinks he might be sampling in that area. I'm a real advocate of lag sampling. As I said, I think it's been largely forgotten. It's a great way to get rid of the aeolian dilution. There are other dilutions that you may wish to get rid of as well. We refer to it as sweeping up the countryside. So a dust pan and brush is a great way to start. Into the sieve, the minus fraction goes into the ground and the plus fraction actually goes to the lab. So I just want to talk about a few case studies of orientation, just to give you my bent on what I think you should do in terms of orientation. This is from a gold project in Western Australia where 30 unsieved samples were sent to the lab. They were sieved into 5 fractions by the laboratory, and they analysed the 150 samples. And it was decided from that that the -6 mil fraction was the best for regional sampling. So they took a +6 mil, a very coarse lag, some finer lags, and then down to -180 micron, which you may well know as -80 mesh. It's interesting to actually have a look at the data itself, because the sample medium that gave the best background to anomaly ratio, and if you look on the left-hand side, you can see this is a log scale. So we're talking about quite significant differences in through here. Basically, when you have the +1 mil material, so the 1 to 6 and the +6, and perhaps even the 0.5 to 1 mil, excuse me, that appears to have the best background to signal ratio. Now, the -180 micron or the -80 mesh actually has the worst background to signal ratio compared to the other fractions in this area. And when you go for a bit of a walk in the area, it becomes pretty much obvious as to why that's a case. So this area here, a Regolith Map had already been done. So we went out and walked the ground. This is the same area where that orientation had been done 10 years previously. Took a G-hammer, a couple of sieves, a spade, and walked some traverses. And it's pretty obvious after you spend 15, 20 minutes in the area that that -80 micron material, -80 mesh material, or anything that's probably less than about 0.5 is aeolian louse or fine grained sand in this particular area. Pretty much a dilute. So without sending any samples to the lab, so we haven't wasted, if you like, haven't spent 150 samples and also spent maybe or lost 6 weeks. We can actually do orientation by walking in the field and deciding what the correct methodology would be in through here. And it pretty much was apparent after a short period of time that taking a +1 mil sample here was probably the best sample medium in the area. So just if people are interested in learning a bit more about 80 mesh, because quite often I hear people say this is the industry standard for soil sampling. There's a beautiful article written by Bob Garrett from the Geo Survey of Canada. It's on the Association of Applied Geochemists website, the Explore magazine. And he talks about the development of -80 mesh and talks about how it's been extremely successful, primarily for the discovery of base metal deposits around the world. But he does put this caution in the very last part of it. You know, we have to be aware we shouldn't take -80 mesh for granted. And in particular for precious metals, because we can actually see that -80 mesh doesn't work necessarily very well for -80 mesh. So I've got an example here of that, of some samples that were replicated. by -80 mesh and also done at -1 mil. You can see the copper lead zinc is in good agreement, which is basically what we've found since the 1970s with the soil sampling. But if you actually look at the gold, antimony and arsenic values, which are the lower three split probability plots, with the red being the -80 mesh and the green the -1 mil, on average, gold is 45% lower and antimony is 50% lower in the -80 mesh. And part of that is because the -80 mesh samples were not pulverized. And that's one of the reasons why -80 mesh became a good sampling medium. You could have pulverized that -80 material and that may have negated some of the underreporting. However, if you had only done -80 mesh in this particular area without the replicates, you would have missed an area of mineralization. So the reason they did sieve to a fine mesh was to save the sample preparation stage at the lab. But in fact, this actually ended up being a false cost saving. So I do a lot of work looking at dirt in the field, but as far as I'm concerned, that's not where it ends. You need to send samples to the laboratory, and this is also a really important stage. So again, keep asking that question. What are you trying to achieve? Are you trying to get a hole in one? You know, do you want to directly detect mineralization? You're searching for copper, you're searching for gold. So just analyze for those two. Or maybe you're actually interested in landing your first lot of sampling on the green, a near miss. You know, it might be slightly buried. So you might be actually interested in pathfinders. You might, if we're talking the regolith, you're probably looking for elements that will hold up in the regolith or actually disperse favourably for you. Alteration's a bit more difficult, but if you're actually in saprock or a bit lower down, the alteration may actually give you these near-miss indicators. You may actually still just want to know whether you're on the right fairway, whether you're still in the right rock. So lithogeochemistry can actually be in there. Quite often I see people fairly early on in what I call the bunker or the lake. They've either used some sort of non-optimal sample preparation, some bad digestion, or the analysis method is not actually achieving what they want to get to. You may have seen something similar to this. This is a comparison of Aqua Regia digestion versus 4-acid digestion. The Aqua Regia in red, 4-acid in green. There are log-log plots, so if they're separating, it probably means there's an order of magnitude difference between the values there. And this is in saprolite, it's not in fresh rock, so there's a chance here that the Aqua Regia is able to actually work on weathered material, and quite often people say, well, Aqua Regia works wonderfully in weathered material, and it does in highly weathered material. However, it may not for the work that well for the elements that you're looking for. Just another one talking about Aqua Regia versus 4-acid digest and looking at ICP versus ICPMS. There was a company that did some diamond drilling and they analysed their samples by Aqua Regia. The petrology, and you can see one of the rocks down below there, showed strong carbonate alteration and widespread albite sericite alteration. So I've put up a plot here, an alteration plot from Cliff Stanley and one of his students, Medeski, from 25 years ago. Some people call it a GER plot, but the basic thing of it is in the centre, you can see a zone of unaltered rocks plotting in through there. If I've got sodic alteration, my sample should go to the right-hand corner where the albite node is. If I've got any sort of white mica or case bar alteration, it should be heading off in that sort of northwest or westerly direction on the plot. And the current samples, as they stand, you can see with the Aqua Regia, they all plot in this corner and through here. The company didn't find any mineralisation and walked away from it straight away. So Company B came along, the drill core sits in the Mines Department core shed, and they reanalysed a selective amount of core, about 1 metre every 10 by 4-acid digest of that particular drilling that sits in this area here with the Aqua Regia. And immediately with the 4-acid, we get a much more different story. and the ICP is seeing the alteration that was recognised in petrology. We're seeing sodically altered material, and we're also seeing white mica material. So sericite is actually, it was described in the petrology. So does that matter? Well, yes. Also sampling some earlier drill holes from 30 odd years ago for low-level pathfinders showed that white mica alteration in the first drill hole was associated with some elevated pathfinders, antimony, bismuth, thallium and tin. And also the sodic alteration was associated with elevated tin. An older hole from 30 years prior, which had never been really analysed by any low-level detection method, also showed some white mica with the thallium and tin elevation. So the ICPMS sees the alteration, and there's also revealed an intrusion-related pathfinder signature. It's a distal signature to mineralisation. So it comes back to that question of what are you trying to achieve? You can get alteration pathfinders. You know, if you want to know that sort of thing, then you've got to look at 4-acid digest ICPMS, or maybe even a lithium borate fusion. So how do you know if your current sampling is actually rubbish? Well, hopefully it's only just a little bit diluted. The material on the left here is one of my favourite slides to show. You can see there's a little bit of quartz and iron-rich gravel in it with a background of sandy soil. Previously, there'd been quite a lot of soil sampling in the area, -80 mesh, and the results are really patchy, really hard to get any sort of coherency out of the material. But when you actually find a cutting, and this was just a gravel scrape on the side of the road, the story actually explains itself very, very nicely. There's a boundary here between transported material, exotic, aeolian, sand and louse, and this white quartz, and then very weakly weathered bedrock there. So this material here, it's 20 centimetres to a metre thick, is basically inert to geochemistry. And in fact, in this particular zone in through here, there's just a little bit of material that's actually soil that's preserved in the area. But if you take a sample, even there where the G-pick is, you will get basically nothing that reflects what is actually occurring within the bedrock in through here. This material is post, if you like, the last transported weathering event. So to finish with, I want to throw in some thoughts about how we define cover, and maybe we need to have a conversation about cover. I found that Google is very confused by cover. When I actually typed in the word cover, what I got was basically someone who could reupholster my furniture in orange. So we talk about transported cover in the ILGAN, we might talk about Permian cover. I've heard of in situ cover, and we've had a few initiatives that were uncover and undercover. So it's made me wonder what really we should be referring to when we do talk about cover. And if we have a look at this diagram on the right here, and it's one of Ravi and Moon's from 20 odd years ago now, you can see that we actually have dispersion into all the units below the yellow. So basically the saprolite, the Permian sediments, and what they've labelled here is tertiary sediments. And you can see there's a chemical dispersion footprint, the red in through here, which basically matches up where a paleo water table has been. And that's a really important thing, I think, to actually realise that, you know, we have the potential to mobilise material where there has been some sort of paleo water table. And I think, you know, one of the things with that paleo water table is that we actually need to appreciate that this material here, which is called tertiary sediments, is actually pre the last tropical weathering event. So I define cover now as material that is actually post the last tropical weathering event. And if you like, that is cover. It's inert to geochemistry and also known as what I refer to as rubbish in that regard. So these tropical weathering events is something I think we actually need to think about very seriously. So, and this again, it's not a new concept. We're going back to 67 here, where Strakov, who's a Russian, actually defined these things. where you're starting to see weathering down to 40, perhaps we would even think 50 and maybe deeper meters, so that we can actually get elements getting mobile in this area in through here. So if we are in a particular area, we actually need to define when the last tropical weathering event was. And that could be regional. It's going to vary in different places in any country at any particular time. And in the southwest Yilgarn, we have an Archean basement in through here. We know the last tropical weathering event with the humid seasonal was probably going on from the Paleocene to the mid-Miocene. So if we have any pre-Neogene material in the area, they are potentially transmissive to any sort of remobilization of material. Anything after the Miocene is basically going to be not samplable material. So what I started to realise when I actually putting this together is that, you know, what we need to do is go back and recharacterise the regolith units with good old geological logging. Probably the major thing we can actually add to what's been done probably in the last 20 to 30 years is when we profile sample from the top to the bottom of the weathering profile, we start using some low-level detection ICPMS or better to actually see what sort of pathfinders are actually carrying on through the regolith. And when I've done this in particular areas, we're starting to see things that actually haven't been seen before. Age dating, that's getting out of my sphere, but I'm going to throw that in because I think it's really important to know when these tropical weathering events have been conducting. And this is just one of my particular little bents. I would love people to actually start realising that when you're actually in the weathering environment, unless you're talking about immobile or relatively less mobile elements, you actually need to appreciate that iron, manganese, even aluminium can start moving stuff around. So if you look at it in a univariate space, you will actually not see what is really happening here. So to conclude, start at the end. Work out what you're trying to achieve. Are you going to go straight from the tee to the hole, or do you think you might actually have a few shots on the fairway on your way into the green? We need to understand the regolith, and the tropical weathering event, I think, is a really, really important thing to understand. You really need to work out what the appropriate sample meeting area is, determine what spacing you actually need to do, your methodology, and please, the analytical procedure and the technique are really important. So complete a program, assess your results, and revise what you need to do after that. And look, regolith is all about what we sample. Regolith is not there just purely to produce a very pretty looking geomorphological map. It needs to be clearly focused in the exploration sense on what we sample. And this regolith stuff, you know, is not new. I found this the other day in a publication from Olia, who did a huge amount of work in the 70s and the 80s. This goes back, and a lot of the terminology that we started using in the CSIRO and CRC lean came into existence from work that Walford did in 1915. And to finish off, I'm going to let one of the Cliff Ollier have the last word. We do the best we can to map the partially understood into potentially helpful maps. So please get out there and map, and then you can actually start sampling. Thanks, Jess.